Hey, this lesson is on ordinary differential equations. So this is the last topic in Math 176, and you learned how to solve growth and decay equations and also equations using separation of variables. And the remarkable fact is that there's an extremely simple command in Maple that will allow you to solve almost any ordinary differential equation. So the goal of this lesson is to learn how to use Maple to solve ordinary differential equations with or without initial conditions. And the fundamental command is simply Dsolve. Remember, to solve equations, we would just use solve. Or to solve in floating point, we would use fsolve. To solve a differential equation, the command is Dsolve. And the notation we use is the following. The unknown function, the solution of the equation, is going to be denoted by y of x. And the first derivative, we write diff y of x comma x. So when you do that, this is how it appears on the screen, dy dx. When you need the second derivative, you write diff y of x comma, and then two x's. It means differentiate with respect to x and then again with respect to x. And when you look on the screen, that's how it appears. So in order to use the Dsolve command, you need to write down in some fashion the ordinary differential equation you want to solve. So here's an example. I'm just going to use the notation ODE for the differential equation. You don't need to use that. It's convenient, but you can use any other letter or words or symbols you like. But I assign to ODE this expression, diff y of x comma x equals 7y of x. So what is that? It's like dy dx equals 7y of x. So this is an exponential growth equation. It's the simplest kind of equation there is. And you know the solution is a constant times e to the 7x. So let's just check. How do we solve this differential equation in general? The general solution? Just write Dsolve this ordinary differential equation. And this is what we get. So you know the solution, you know from calculus, the solution is just a constant times e to the 7x. This underscore C1, that simply denotes a constant. So this is the general solution, some constant times e to the 7x. So here's some more examples of first order. That means the highest derivative is the first derivative. I mean, in most differential equations that come up in the beginning in math and physics and chemistry and other places where mathematics is used, they're usually either first order or second order equations. So all we need is the first derivative of the second derivative. Let's see, here's some more examples. This is dy dx equals y of x squared. So that is what's called a separable differential equation. You could solve it by hand, but right, that's it, dy dx equals y squared. And what is the general solution? That's it. This is 1 over, this is minus x plus a constant, or 1 over any constant minus x. That's the general solution. You should solve it by hand because you're supposed to be able to do that and see that it works. Here's another exponential differential equation. Sorry, another differential equation. It's dy dx is y squared minus 2y of x. So again, this is separable. You could do it by hand. It's a little bit of work. But if you say to Maple, solve the ODE, ordinary differential equation, there it is. Wow. It just did it for us. It's 2 over 1 plus 2 times some constant, whatever it might be, a general constant, e to the 2x. Here's another differential equation. dy dx is y squared minus 2y plus 1. What is the general solution? some constant plus x minus 1 over the same constant plus x. And there are other ways to write it, but that's the solution. What about second order ordinary differential equations? Here's an example. The second derivative of y minus 4y is 0. What is the general solution? There it is. So this involves two functions. These are like the fundamental solutions, e to the 2x and e to the minus 2x times some constants, different constants, c1 and c2. Suppose I change the equation slightly. Instead of a minus sign here, I now have a plus sign. What do those solutions look like? Constant times sine and another constant times the cosine of 2x. That's the general solution. Now, very often with a differential equation, in addition to the differential equation, there's some initial condition that also has to be satisfied. Usually, if it's a first order equation, there's one condition. If it's a second order equation, there are two conditions. Typically, the function and its derivative have specific values at x equals 0 or x equals some other number. So here's an example. So here we have a differential equation. This is a simple equation. dy dx is 4y. So again, we know the answer before we start. The answer is going to be a constant times e to the 4x. But now I impose this initial condition. The initial condition says my solution should also satisfy that when x is equal to 0, the value of the function is 3. So here's how we write. This is the syntax for solving an ordinary differential equation with an initial condition. And what is the solution? 3e to the 4x. How do you check? Well, when x is 0, this is 3. And when you differentiate, you get 4 times y. The initial condition doesn't have to be when x is 0. It can be, for example, here when x is 1. So if we change the initial condition, so the solution of 1 has the value 3, when we solve this differential equation with this initial condition, that's the particular solution. 3e to the 4x over e to the 4th. And again, you can check. If you let x equal 1, I get 3e to the 4th over e to the 4th. The e to the 4ths cancel, and you're left with 3. Here's a second order differential equation. We saw it before. And now I impose an initial condition, which is y of 0 has the value 1, and the derivative at 0 has the value 5. So this is the notation. And now the solution of this differential equation of order 2 means the highest derivative that appears is a second derivative. What does the particular solution look like? That's it. 7/4 e to the 2x minus 3/4 e to the minus 2x. Again, when x equals 0, you get 7/4 minus 3/4, which is 1. And if you differentiate, and then x equals 0, you get 7/2 minus 3/2. Sorry, you get 7/2 plus 3/2, which is 10/2, which is 5. So this all works out. And you can check explicitly. If you substitute x equals 0 into the solution, you get 1. And if you substitute x equals 5 into the solution, you get 1. So that is really everything you need to know to solve a differential equation. Let me do one or two from the homework in Math 176. So this is in section 6.3. The homework was 1 to 17, the odd numbered problems. So let me do number one. So this is section 6.3. Exercise 1. So we have the ordinary differential equation, ODE. We let this be the first derivative of y of x with respect to x equals x over y. Find the general solution. So we just write Dsolve let's see, let's try this. There we are. So the solution is square root of x squared plus a constant, or minus the square root of x squared plus a constant. So this differential equation has two solutions. If you solve this equation by hand, that's exactly what you get. What about, I'll do another one too. Number 9. So in number 9, the differential equation is y times y prime. So that's y of x times the derivative of y of x with respect to x equals 4 sine x. Y times dy dx equals 4 sine x. If we desolve the equation, that's the solution. Again, there are two solutions. It's plus the square root of minus cosine x plus a constant, or minus the square root of minus 8 cosine x plus a constant. Let's look at some initial conditions. So let's look at exercise 15. So in this case, we have the differential equation y prime minus 2e to the x equals 0. So that this ODE be equal to y of x times the derivative of y of x with respect to x minus 2 times e to the x, which I have to write as exp of x, equals 0. So y dy dx minus 2 e to the x is 0. And I have an initial condition, which is that y of 0 is equal to 3. So Dsolve what? The initial condition and the differential equation. And that's the solution. See, if you plug in x equals 0, you get the square root of 9, which is 3. And you should check, if you differentiate this times y of x, that's what you should get. Let's do one more. Let's see. The homework went up to 1 to 17 odd. So let's look at number 17. Y times x plus 1 plus y prime equals 0. So let the ODE be y times x plus 1, so y of x times x plus 1 plus the derivative equals 0. And the initial condition is that y at minus 2 is equal to 1. So that's Dsolve, the initial condition, and the ODE. And the answer is e to the minus x times x plus 2 over 2. Let's see. For that x equal minus 2, you get e to the 0, which is 1. And if you differentiate this, well, this is what you're supposed to get. And you can check that by hand, I guess. So that's pretty nice. This is using Maple to solve differential equations. Solving differential equations is always hard, but amazingly, all you need to know is the syntax for the dsolve command, and you can solve a lot of equations. Okay, so that is the last part of the syllabus for Math 176. And so we're not going to be doing anything new after this, but I will send out a review sheet for the final. And again, I remind you, I have office hours Monday, Wednesdays at 1 o'clock, and other times as well. You send me an email. Very few people use the office hours, but it's a wasted opportunity because it's a way to learn Maple a lot better. Okay, that's it.